know, 5 to 10 users, and then I wanted my users to start playing the game, how would I know which user is doing what, right? That's where the self comes in. It allows us to kind of specify this specific user. This user has this attribute or has this method, is invoking this method. Andrew says self is a lot like this in JavaScript, right? And that is hitting the nail right on the head. Yep, that's exactly right. They're equivalents. Cool. So like I said, we'll build a little game here. So maybe I'll accept a username. And maybe if we have time, we could implement random, make like a random number game. Let's see what we have time for. I know that username will be something that varies from user to user, so maybe that'll be the only parameter that this accepts for it. Now here's where our self comes in again here. Self.name equals username. What does that line of code mean? Self.name equals username. What does this mean? Right. The username
means itself.
Passed in. If I create a user and I pass in Peter, then this user that I'm creating, this user, that's where the self comes in. This instance of user will have this username Peter, right? We can also create some attributes, and that's what I'm doing here. This name is an attribute of user. All users have a name attribute. All users also have a score attribute that I'm going to begin at 0. Right? I'm going to begin this score at 0. Now I'm going to go ahead and create some users. Let's make Mark. Mark is a user. We can use this new user, I believe. Let's see if new yells at us. No, yeah. New user. Really driving home the point that I'm creating a new user object. This new keyword is kind of new, but it's nice to implement. And it, like I said, it drives home that point of I am instantiating an object here. And whenever I'm invoking the class name, like I'm doing here, whenever I say class name user, and I have those open, close parentheses invoking or calling that class name, what that's really doing is calling my, my constructor function. I am calling my constructor. We can even see that whenever I am hovering my cursor in there, it was telling me, hey, I'm expecting a username. I'm expecting a username from you, so let's go ahead and pass in a username. Is it like new, or is that a JavaScript thing? JavaScriptism. Yeah, new yells at you.
I guess you can't use new.
Cool. So check out what happens whenever we print that object. It's not quite what you see whenever you print like a dictionary, right? User object at this place in memory. All of these digits we're seeing, all these characters are just the place in memory where our object is stored. Cool. So I've instantiated a new user by calling this constructor function. I passed in this username, but where's the self getting passed in? I didn't pass in a self. Where's that coming from?
Already implied.
Yes, Andy, exactly right. This variable, Mark, the variable in which we are storing this instance of user, is the self. Mark.name equals Mark. Mark, variable Mark, dot score equals 0. Exactly right. This is the self. This instance of user. So if I were to put mark.name, what do you guys think is going to get outputted in my terminal? Mark with that capital M, right? And you guys would be exactly right. You guys would be exactly right. So here, whenever I am accessing object attributes, I can use dot notation. We were talking a little bit on Wednesday last session and during office hour about accessing dictionaries and how we use bracket notation. And this is where starting to kind of draw that line in the sand between dictionaries and objects becomes important, because here, accessing these object attributes, we are using dot notation. But when we are accessing dictionary keys, we are usually using that bracket notation, right? Jenna asked a really good question. When was score passed in? And it wasn't. Score wasn't passed in. Not all attributes need to be passed in by the user. Now, some of them will be. Thinking to your guys' assignment, I'm sure many of you have looked ahead and saw that you're going to build that bank account assignment, right? Well, what are things that a user would have control over in their bank account? Well, they'd have control of like the type of account. Maybe they could pass in savings or checking. Maybe they could have controller of the start amount, right? Maybe. Or the start amount could just start at 0 and they could deposit money, right? So there will be times where attributes are just static. In this case, we're building a game. And I don't want to give the user the option to just pass in a score, because then they could pass in a score of 1 million and just, win the game without having to put any effort. So sometimes attributes can just be static like this. We don't need to accept them as parameters. Cool. I'm going to answer some questions here in the chat. So Andrew says, did username pass the argument mark when you executed self.name equals username? Yes. So what's happening on line 6 is, up to this point, I have only written the blueprint for users. Much like whenever you guys write your functions, right? That function does not actually run until it is invoked or called. So I've written this user blueprint, but I have not created any users until line 6, where I say mark equals user mark. I invoke this constructor, and I say mark.name equals username mark. I've created this object, stored it inside of mark, and mark.name is this mark, this string mark. Mark.score is this integer 0. Yep. William says, but can be changed by user inputs. Yeah, what if Mark wants to change their name? What do you guys think I would do to reassign the name?
Mark.name equals. Yeah. What if I said mark.name equals
Marky?
Mark? Now what if we print mark.name? Oh, we'll check that out. There's Mark's new name. Thank you, Andrew. Thank you. Beautiful. So yeah, we can access these values. We can change those attributes. I saw another question here. Is it correct to say that attributes are variables encapsulated within the class that you can only access those attributes? Is to instantiate an object, the object's access to its attributes and methods. Right. It's safe to say, or it's a good way to think about this data as variables only associated with this instance of class. What's cool about this is now we know that any user I create, I could make all sorts of users, but all of them are going to have a name attribute, and all of them are going to have a score attribute. And the data that is pointed to whenever we look at different objects, name or score attributes could vary. Different objects will have different names. If I create a Andrew object, well, their name's going to be different than the Mark object, right? Exactly right. Name and score are attributes, not methods. We'll start building some methods here in a moment. Exactly right, Andy. Methods will be defined with that def syntax. Now, Kevin points something in the chat, if you guys check it out. It looks something like this. He says, would this work? And he says, if we were to replace definite and pass in the data right here, say like Mark, the answer is no, because remember, this is a constructor method. Methods are just functions that exist inside of classes. That's how I want you guys to think about methods. Methods are functions that only exist within a class. So this is a constructor method or constructor function. And remember, functions accept parameters. If I passed in Mark and Mark right from the get-go, that would kind of defeat the purpose of writing this class. I want to write this as a blueprint. That way I can go through and create other users other than Mark too. I can create Andy, right? And I can create a different user, Kevin. Now, if I passed in Mark up here, then I would have to write class user for the amount of times I wanted to create new users. But instead, I've written the recipe for a user once. And now I can go and instantiate as many users as I want. Yeah, we need some girls up in there. Andy says we need to make some girls. I know Hannah's in here with us. Welcome to the party. Cool. So we have some attributes. We've discussed the constructor method, class attributes. And what about just our normal class methods that we can write? David says, what is this weird science? Cool. So I want to create a new method here. Maybe we could make a method that allows for users to say a greeting. They could say, hello, my name is Mark. Or hello, my name is Kevin. Hello, my name is Hannah. Right? So I'm going to create a def greeting. All of the methods that we write must accept the self as a parameter. All of the methods that we write will accept the self as a parameter. Reason being, we have to know what instance of user is invoking this method. Is Mark doing the greeting? Or is Andy doing the greeting? Is Kevin doing the greeting? Hence the self, right? Now, if I wanted to have a nice print statement that prints a greeting, what would be a good way for me to do that? Andrew says self allows the environment to be dynamic. Self allows for you to know which instance of user you are referring to. What instance of user are you referring to? Close, Kevin, close. Now, I don't need to make a new attribute. I can simply print something. Maybe an F string. What if I print a little F string? And I say, hello from, and then what would be their name? How could I access their name? Self.name. Self.name. Right. Self.name. This particular user's .name. Beautiful. Now, how would I invoke this method? I'm going to go ahead and get rid of this print statement and this one so that we just have a few users. So here is where we are instantiating some users. Now I want to say a greeting. How would I invoke that greeting method? Yes, mark.greeting, and then call it. It is a function, right? Remember, methods are functions that belong to some class. So I can't just call greeting. You know, this is not a global function where I can just invoke the greeting function. It does not exist, even if I do type it correctly, right? It does not exist. Look at that. Undefined variable greeting. It only exists within the scope of a user, right? This method belongs to a user object. If I want access to that thing, I need to have a user object. This is Mark doing the greeting. So what's our output going to say? Well, hello from Mark, because our self here is Mark. Very nice, very nice. Now there's something really cool that you can do with class methods. And you can only do it sometimes because other times these class methods need to return something, right? Sometimes you'll want to write like what are called getter methods that retrieve some data, return some attribute. Like maybe we could write a method for retrieving the name that returns the name, or a method for retrieving the score that returns the score. But whenever you're writing a method that doesn't necessarily have to return anything, like in this case, where our task was to write a method that prints a greeting, well, I don't have to explicitly return anything. So what I'm going to do is return self. Return self. Now this looks pretty crazy, but what am I doing here by returning self? Well, remember, self is just an instance of user. Self is an instance of user. So whenever I return the self, that means that my function evaluates to an instance of user. My function evaluates to an instance of user. And this allows for what's called chaining methods, because instances of user have access to these methods. So now I can chain this greeting method all day long, because after printing the greeting, hello from Mark, this just evaluates to Mark. Well, Mark has a greeting method that we can invoke. After printing it, it evaluates to Mark, because we're returning self, returning Mark, right? So we can see this method chaining occurring. Yeah. So Andy has a question. He says, on a class object, you can access the attributes and method with the dot notation. If so, is there a way to know if it's an attribute or a method, or do we not care? Yeah, well, I mean, usually you will have written the classes yourself, so you'll know what you're working with. If you try to just say mark.greeting and you don't invoke it, nothing will happen, right? So that'll be kind of a giveaway that you need to invoke the function. Kevin says, why would you want to chain a method? Why would you want to chain a method? It saves time and it saves space. Saves time and space. There are times where you want to do a whole series of operations to a piece of data, and doing it like line after line would just look cumbersome. If you were maybe dealing with a queue, queues are data structures that we write with classes. We could write a class queue and write all sorts of class members or class methods that belong to this queue class. Things like adding to the back, add to the back of the queue, add to the front of the queue, right? All sorts of stuff like this. Now, with this example, it becomes a little more apparent why we may want to chain methods, right? If I wanted to quickly add a whole bunch of data into my queue, then I could do so all in one line. Dot add this piece of data. Dot add this piece of data. Dot add this piece of data. As opposed to having to take up like 20 lines in my text editor doing so. You can chain different methods with one another. Certainly you can. So what's also cool is we can make classes, or rather class instances, objects, interact with one another. So what if we said def greet another user? What parameters would this method accept, do you think, if we want to chat with another user?
You need user 1 and user 2.
And this is going to lead to answering your question here, Kevin. Exactly right, Andrew. The self, because all of our methods need the self, we have to know which user is invoking this function, and another user. Another user. This works just fine, as long as whenever we invoke this function, we pass in another user. Right? Now, this is going to be a greeting to the other user. So maybe I could say self.name says hello to
another user.name.
An entire user object into another user. How would I access their name here?
Name.
How would I access their name?
Name.
Another user dot name. Exactly right. Another user dot name. We're passing in a whole user object here. User objects have name attributes, they have score attributes. So this will work just fine for us. So now I can have Mark say his greeting, that returns self, and then I can have him greet another user. Maybe he could greet Kevin. Hello from Mark. Mark says hello to Kevin.
Wow.
And if I wanted to be able to chain this method,
your penis. You're done. Never again.
What correction would I have to make? Because right now, let's see what kind of error we get. None type object has no attribute greeting, right? And Gustavo says we need to return self. Right now, we're returning none. We're returning none. So none type has no attribute greeting, doesn't exist. If we want to have the attribute greeting, well, there's only one thing that has this attribute, and it's a user. So let's make sure we return an instance of user, return that self. Yes, Kevin, chaining super cool, chaining super cool. And now we can greet everybody. We can go around the horn. We can greet Hannah. We can greet Andy. And there we go, saying hello to everyone, like a friendly neighbor. Look at that. Very cool. Right, Andrew, right. If you do not return the self or an instance of user, then you're not going to have access to any of these user attributes or methods. You have to return an instance of user in order to have access to that stuff. Cool. It's under view. I think it's Command Z or Control Z. Alt Z on Windows, David says. Cool. Awesome. Any questions regarding chaining methods or these methods that we have written here? Feeling good? Yeah, this OOP stuff kind of makes sense. You can see the application. You can really see the practical application. This is used very frequently in games, which is why I kind of took this game approach. Because of like polymorphism, encapsulation, these pillars that we've discussed, right? It's easy to make a class mob and kind of have a really diverse range of mobs, right? Maybe they all have different amounts of health. Maybe they all have different class or like type, you know. And you could really go buck wild with how creative you get. This is also how maps are handled in games, oftentimes with classes. You can have a class location that has like a north, south, east, and west, right? And by creating connections, you know, this location dot north equals other location. This location dot south equals other location. You create an actual map that can be navigated through in like a text game or whatever. Yes, Andy. Yep. So this constructor method is required in Python classes. Now let's do something that will be kind of required for you guys in the users with bank accounts, and that is having a attribute point to another object instance. Having an attribute point to another object instance. So we have this store. Now let's do something that will be kind of required for you guys in the users with bank accounts, and that is having a attribute point to another object instance. Having an attribute point to another object instance. So we have this store attribute here. We haven't really done anything with it just yet. Maybe we could make a different class, a game class, with its own game methods. And users could have a game attribute. That way, a user could still greet and do things that a user could do. Like maybe in the future, users could even edit their names and things like that. Kind of do like the administrative user stuff. But then if they access their game attribute, user.game, they're accessing an entire other class with other methods, like user.game.guessNumber and things like that. We could make like a number guessing game, right? Cool, let's do it. Class game. Now I know whenever I am creating a new class, the first method that I need to write is that constructor method, def init. Init because it is going to get invoked to initialize new games, right? Now we have to accept the self here. We have to accept the self. Maybe we could also accept a random number or a guess. Let's make this a number guessing game where users, whenever they invoke the game, whenever they start the game, they pass in a guess between 0 and 10. And we could tell the user if their guess was too low, too high, or just right. And if it's just right, they win, right? So maybe a parameter we could accept here is that guess. Cool. So self.guess equals. And we could also, whenever the game is created, we could also create the random number as an attribute of the game, the number that's being guessed towards.
Import random.
We have a nice library that we know we can use, random. Do you guys remember how to create a random number between 0 and 10? If I wanted to create a self.random, maybe rand number, what would that look like? Right, Kevin, random.random times 10. Beautiful, beautiful. Now, if I want users to have a game, so now I could say something like self.game, users have a new attribute called game, and it is an instance of game. We'll notice that we're missing something. That guess, we need that guess. So how am I going to get this guess? What is going to be required of me in order to get this guess? An input, exactly right. Whenever a user is instantiated now, they need to give me a guess. They need to give me a guess. Exactly right. Cool, cool. So now let's see what our users behave like. I'm gonna get rid of some of the spacing. Now it's yelling at me because, hey, you didn't pass in a guess. So start spitting your guys' guesses out for me. Mark, Andy, Kevin, Hannah, what do you guys want to guess? 4, 5, so Kevin said 4. Mark said 5. Hannah says 8. Andy? Winner auto passes the exam, yes. Winner doesn't have to take the exam. Winner teaches class. None. Ooh, getting crazy in here. Okay. This I'm gonna replace this with 0 just so I don't have to do type stuff. Just so I don't have to do any type stuff for our comparisons. Oh, snap. Okay. So now our users are all corrected. We're accepting this guess. I saw a really good comment in the chat that said, does it have to be self.guess? And the answer is no, because remember, what we are assigning, the variable name or attribute name, is on the left and the value is on the right. So this guess that we're passing in is the value that we are assigning the self.guess of our instance of game. Yeah, that's a really good call, Anthony. Otherwise, nobody's ever going to guess it, right? Good call. this is a round method. We'll just round this number so that it's not a float. If not, then we'll get like outputs like 6.27654, right? And none of us are guessing anything that crazy. So now before we write the game methods, I want to take a moment and dissect what we've done here whenever we look at mark.game. It's an attribute that we have now. Much like we have a name, we have a game. Let's see what gets outputted. Game object at this location in memory. It's a lot like whenever we just print mark, right? Whenever we print these objects, it doesn't give us too much. But at least we know that we are in fact accessing an object. We've instantiated an object. Now, mark.game has some of its own attributes, like guess. So maybe I can look at mark.game.guess. There's that guess, and we can see that Mark guessed 5, right? Now we could ruin the game for ourselves and look at the random number, but I won't do that just yet. Very cool. So we see how we're able to, again, peel back those onion layers. Mark.game evaluates to an instance of game where we have passed in this guess and instantiated a new game. Very cool. Now let's write our game logic. Def gameplay.
Gameplay.
Takes in the self. Our guess is there. The random number's there. So all that's left is for us to write some conditions, right? So I need to do some comparisons. If self.guess is greater than self.randNumber, then let's print
Number
guess
too high.
Else if self.guess is less than self.randNumber, then we can print
Guess
too low. Else, if it's not too big and it's not too low, then that means you guessed correctly. Yay. And we could even return self so they could play over and over again and put in many, many guesses, right? If they would like. All right, let's give it a shot. Mark.game.gameplay. Oh, guess too high. And then this gets printed out. The game object got printed out. Why? Why did the game object get printed out?
Because you have it in a print statement.
Right, right. And what's getting returned?
The
Object.
Boom, boom. So we're returning an instance of game, right? We're returning an entire game object. So after running this function, we print out guess too high, but then we're also printing what this evaluates to, which is the self. So we're seeing that object get printed out, right? Very cool, very cool. So our guess was too high. Maybe we could make something where we can change our guess. Change guess. What would this have to accept other than the self, of course?
New guess.
A new guess.
Exactly right, a new guess. And we would be reassigning that guess attribute. Self.guess equals new guess. I have updated, reassigned that guess attribute, and I can return self. So now we could play the game. We could change our guess, right? Go ahead and change guess to a different guess. And then we could play the game again. Oh, you guessed correctly. And then that second time, guessed too high. Very cool. Very cool. And everybody can play the game. See how Hannah does. Ooh, too high, too high. Here, let's change this to maybe a 3. Oh, too low, too low. Man, oh man. But that's what's good about chaining these methods, right? We can give ourselves plenty of opportunities. Oh, snap. Very nice. Very nice. Cool. Any questions about having a class as a attribute of another class. You guys feeling pretty comfortable with this idea? Meh. Gonna take some time for sure. Yeah. Yeah. The reason that I took it this route as well is because you'll find that what we've done tonight will be very similar to your users with bank accounts. So feel free to reference this this video, and perhaps I'll post this oop.py to our Mattermost channel just for you guys to reference. Because what you are doing with your users with bank accounts will be very similar here, where users will have an instance of bank account. You'll be writing methods to affect other users' attributes, right? So we can access another user's name. Well, we could change another user's name, right? And maybe make deposits into another user's account and things like that. So continue exploring this. I mean, OOP is really the bread and butter of modern programming, and we'll see more and more how it comes into practice. And if you are getting like discouraged at all, or for any point you're like, what is the point? What's like the application, the practical application of this? I implore you to look ahead to the Django ORM and take a look at the syntax, how close this resembles the class syntax we're doing now. And just keep in mind that all of this will culminate in us building these full stack web applications. And the reason we're building these classes is, well, it's important fundamentally to understand OOP, but furthermore, we're going to be writing these classes to act as our tables, our database tables, right? So all of this serves a purpose. I look forward to meeting you guys and doing some code review throughout the week. It feels so long, like that gap between Wednesday and Monday feels so long. I miss you guys. So schedule this time together and we can do some pure programming if ever you run into some hurdles. Time to create mud. Awesome, guys. Well, I'm going to get this uploaded for us to the platform. I'll get this uploaded to the Mattermost, like I stated. Ping me with your guys' questions and have fun.
All right, taking a break. See you back in about 10 minutes.